All right, biochemistry is just organic chemistry in review. Here's proof. A trinucleotide has a bunch of functional groups we've studied all semester. Trinucleotides are the start of building things like DNA and RNA, right? DNA has oxygen missing on what carbon of ribose? The second carbon. First carbon has the nitrogen. So in black, your answer must have the black part first, regardless. So anything in black here, you have to have. It's the skeleton, you start with it. Notice I didn't finish that O, I didn't finish the N. We have to know how to draw phosphate esters and phosphodiesters. That's a phosphodiester. Some of you have heard of those. Do it again. Do it one more time. Nitrogen every time. Oh, that is your minimum that you're going to have for every possible version of this question. Watch this. Only on that ribose is there an OH on carbon 2. The others have a D in front. 2-deoxy. Deoxy G. Just deoxy. There's your D. This is not a natural trinucleotide. Natural trinucleotides have all DNA pieces or all RNA pieces. But this is a lecture course. We can do anything in theory. Okay? So we got a mixture of DNA and RNA glued together. Nitrogenous bases, I'm going to grab them. I'm going to pause. I'm going to grab them from the information sheet and copy them over here, so we know how to attach them to our ring. And I'm going to pause. We are back, ladies and gentlemen. I copied the DNA and RNA bases from the front of the exam down here. You got to learn. You have to learn. It's this nitrogen. It's this nitrogen. It's this nitrogen. And it's this nitrogen, and we have to learn ways where learning is not just learning. There's patterns. If you have both rings, what kind of a structure are you? A purine or a pyrimidine? You are a purine. The two purines, which nitrogen did I highlight? Because there's something common to both. In the purines, which nitrogen did I highlight? Because there's something common to both. The one in the 5-membered ring, it's an imidazole, if you want to remember that. And it's the one with an H, because in a condensation reaction, the nitrogen has to lose an H. If you don't have an H, you're not losing an H. You're not making a condensation reaction. So you pick ring size 5, the N that used to have an H. It gets lost in the dehydration step. Ring size 6 only. So the pyrimidines are here and here. I picked, I'm just going to say it, the nitrogen in the ring that's an amide. Done. That means this nitrogen doesn't qualify. It's an imidamide. It's just weird. And it doesn't have an H. Don't ever pick a nitrogen off the ring. It just doesn't happen. It's just not nature. What about this one? Amide and imide. Don't pick the imide. That's an imide. Do you remember what imide means? Between two carbonyls. Yeah, don't pick it. There. So I've got to go and get the G for the first one, and it's here, and copy everything you see. And we'll do it in blue. It goes N up to C-double-N to another ring, and the other ring goes up to a carbonyl and goes to NH, and comes down to C double N. And it's got a guanidine in here. See how I talk now? Okay, I've always been talking like that, I know. But now you know what a guanidine is. It's this chunk here, isn't it? Yeah. Yeah, this building blocks of matter come from things like bird poop. Seriously, break down some amino acids and you can use them as building blocks to make nitrogenous bases and things like that. Okay, enough talk, Dr. Whittaker. What about second one is the U. The U. And U is R equals H, and you connect that. So you don't have to draw anything for R. N goes to carbonyl, goes to NH. Goes to carbonyl, goes to C double C, goes back to N, done. There you go, not bad. What about the C? Here's the C, there's the N, goes to carbonyl, goes to N double C. N goes to carbonyl, goes to N double C. Another urea-ish feature here, but not quite. And then goes to C double C, comes back to N. Did I copy that right? We're on the C. We got the N going to carbonyl, going to N double C. N going to carbonyl, going to N double C, goes to NH2. Yeah, and then C double C. Done. But not done. There's more. Oh, wait, there's more. We need a triphosphate on the 5' end. You got to remember the standard that we agreed to is to list the sequence from 5' to 3'. Left to right. That's the convention is the word I was looking for. I need a triphosphate on the 5' end. Of course, I don't have enough room to draw a triphosphate. I am a spatially challenged person. Now I have room, and that's why he made us draw a triphosphate on that other test 3, I believe, because he was getting us ready to do it again on test 4. There you go. We got to know how to draw triphosphates, diphosphates, monophosphates. In fact, we have a free hydroxyl on the 3' end. There you go, hydroxyl. That was an easy one. See what I did there? Yeah. And I think we got everything. A lot of points. Hydrolysis breaks all derivatives of acids down, and it breaks the ribose down. How many riboses do I get, and how many deoxyriboses do I get? We get one ribose, and it's here. And you tell me what I mean when I do this. Hydrolysis gets rid of phosphate esters too. And you tell me what I'm trying to say right here. La, 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 la. OH. You don't have to draw it like that. You could draw this. Or you could draw this. Or you could draw, oh. It doesn't like me doing Control Y. I think because I was doing other buttons with my fat fingers. This is a representation of a mixture of alpha and beta. OH here, up, is beta because it cis to that. OH down is alpha because it's trans to that. The C sticking off of the ring is the important thing. That is the only definition of alpha and beta. Go tell your biology teacher to stop teaching the alpha means down and beta means up. If that CH2OH was down, these are both wrong. And there are many sugars where it is down. Okay? They based it all on glucose, and then they forgot there's other sugars in life that are important, like blood sugar, blood type in your blood type sugars attached to your red blood cell have an L sugar in them, not a D sugar. Anyway, that's a lot of talk, and we didn't need half of that information, so I'm getting rid of all of it and just copying what I need. Okay. Big eraser. I don't want to put stuff I don't need for the test. That was all just sugar stuff. So you're going to make one of those. It will be a mixture of alpha and beta, but just, I don't know, pick one. There you go. I picked the beta. Okay, and it has the OH. And you get two more of those without the OH there. Thank you. I don't thank you anymore. Okay. I have to draw it again. I don't know why. Two of those. Hydrolysis breaks everything down to their smallest pieces. And hydrolysis buffered at pH 4 too. Oh, pH 4. How many of these do we get? I haven't put charges or H's on yet, but how many of those will I get? I agree. Somebody said 5. There's 3 from the triphosphate and 2 from the backbone, they call it, the trinucleotide backbone. Now, at pH 4, which of these is deprotonated? At pH 4, which of these is deprotonated? The 2.1 only. Guys, those 4 sentences at the top of that document we created the other day, those are the bomb, okay? It says if the pH of the environment is above the pKa of an acid, it is deprotonated. We're just applying that. Those are words. Words are useless, but they help us remember. So only one of those O's is deprotonated. What are the other 2? Protonated. There you go. I will change the pH. I will probably use phosphoric acid. I might use boric acid. I might find another acid. It doesn't matter. I'm going to give you the numbers. Okay? Is that all we get? No. But I don't want to draw my nitrogenous bases again. I'm going to circle everything up to, but not including the N. R1. Please do this. R2. R3. R1, the N is attached to what now when you do hydrolysis? The N is attached to what? H. It got its H back. The one you took off to make the thing is gone, is back because you did hydrolysis. The opposite of condensation. Full circle. Okay, do we get all the pieces? 1, 2, 3, 4, 5, 6, 7. I lied. Where did I lie? Does it say 7 molecules? Greater than 10 molecules? 5, 6, 7, 8, 9, 10, 11. It is greater than 10. Okay, done. Good question. I promise you'll have that question.